Statements from the leadership of CATL, China's leading battery supplier, sounded like a provocation. Elon Musk doesn't know how to make batteries. But while those words echoed behind the scenes, Tesla was quietly busy building a real threat to the Chinese empire. The attack didn't come through speeches or political disputes. It came in the form of a battery, one that recharges in just 10 minutes, lasts over 25 years, cuts costs in half, and, most importantly, doesn't require a single gram of Chinese lithium. The revolution many thought unlikely is taking shape, and it has a name: the aluminum-ion battery. The shift this new battery proposes isn't just technical, it's geopolitical. For years, China has comfortably led the global battery market, driven by its immense lithium extraction and refining capacity. But China's dominance hadn't counted on such a bold move. By swapping lithium for aluminum, an abundant, cheap, and decentralized metal, Tesla isn't just changing the cell material. It's shifting the axis of power of an entire industry. It's as if someone had switched the board mid-game. And the game now is about real performance. With an energy density of around 1,000 Wh, this battery is more than double that of traditional lithium-ion batteries, which typically hover between 300 and 500 Wh. In practice, this means that, with the same weight, vehicles equipped with this new battery can travel much further. A change invisible to those who only see the car from the outside, but absolutely transformative for what's happening under the hood, or rather, under the floor. This density allows not only for more range, but also for smaller and lighter batteries. And here comes a detail that changes the whole equation. Less weight, more efficiency. When the car carries less mass, it requires less energy to move. It's like swapping a full backpack for a lighter one and realizing you can go faster and longer without tiring. For engineers, this translates into new design standards, with more interior space, better aerodynamics, and less component wear. But the impact goes beyond technical calculations. This change represents a direct cut in global dependence on lithium, whose extraction is not only limited, but also extremely concentrated in a few countries. Aluminum, on the other hand, is found in virtually every corner of the planet. And Tesla seems to have understood that the future of electric vehicles isn't guaranteed by performance alone. It requires supply stability and a resilient supply chain. And, let's face it, relying on a single nation in a scenario of geopolitical tensions isn't exactly strategic. CATL's initial provocation, in a way, reveals the discomfort. This isn't a simple technical innovation, but a silent earthquake that threatens the foundation of a billion-dollar empire. If Tesla succeeds in making this battery viable at scale, the current global production model will be rewritten. Companies, governments, and even investors will have to adapt to a new reality where lithium is no longer king, and aluminum, previously a supporting player, takes center stage with surprising ease. And the most curious thing about all this? The impact won't be felt first in laboratories or on political platforms, but on the streets. A car that recharges in minutes, lasts decades, and costs much less, has the power to accelerate the popularization of electric vehicles like no other before. This isn't just a battle between metals, but between visions of the future. While some try to protect what they've already built, others are busy imagining what still can be done. The speed with which this new battery performs completely changes the pace of the game. While traditional lithium-ion batteries still require patience to complete a charge, something between 30 and 45 minutes with the best chargers, Tesla's proposal is different. 10 minutes and you're done. That's enough time to grab a coffee or answer a few messages on your phone. This isn't just convenience, it's a disruption in the way people interact with their cars. Recharging becomes a casual, integrated part of their routine, and no longer a pre-planned appointment. But perhaps the most surprising aspect is its lifespan. Today, a typical battery begins to lose power after 2,000 cycles, which is equivalent to a few years of use. But nothing extraordinary. Tesla's aluminum battery promises up to 15,000 cycles at near full performance, which translates to about 25 to 27 years of life. That's longer than many people keep the same car. This longevity changes the market logic. The most expensive component of an electric vehicle now lasts longer than the entire car. The battery's thermal resistance also breaks new ground. While lithium-ion batteries operate well only between 20 and 30 degrees Celsius, requiring sophisticated cooling systems to maintain the ideal temperature, the new battery withstands extreme temperatures ranging from 50 degrees Celsius to 150 degrees Celsius. This virtually eliminates the need for thermal control systems, reducing both weight and cost. And, as a bonus, it ensures reliable operation anywhere on the planet, from scorching deserts to freezing winters. This thermal robustness translates into design freedom and real savings. With fewer components dedicated to cooling, design space is freed up, and a significant chunk of the production budget is cut. The result? A car that's simpler, lighter, and cheaper to manufacture, without compromising performance. Engineering no longer revolves around adapting the car to battery limitations and instead focuses on something more predictable, durable, and adaptable. It's the kind of flexibility any manufacturer would love. What ensures such performance, however, is the intelligent design of the structure. The battery is divided into two layers with specific functions. The first is the aluminum-ion cell, responsible for delivering constant power for daily use. It functions like a long-distance runner, durable, stable, and reliable. The second layer is the supercapacitor, which kicks in when the car needs immediate power, such as when taking off or braking suddenly. It acts like a sprinter, explosive, fast, but for short periods. This combination of cell and supercapacitor allows for a rare balance between range and power. Instead of sacrificing one for the other, Model 2 delivers both. The aluminum-ion battery handles the marathon, while the supercapacitor handles the sprints. This separation of duties, in addition to increasing overall efficiency, also helps preserve each layer, extending durability and improving the vehicle's responsiveness in real-world situations. Another important detail is that this layered structure also makes the battery safer. The supercapacitor, by its nature, is more resistant to overcharging and less prone to overheating. And because it takes over during peak loads, it prevents the aluminum cell from being overstressed. This balance reduces the risk of thermal failure, which is still a real concern in lithium batteries. Ultimately, what we're building here isn't just a powerful battery, but a smart one. While many still debate the economic viability of lithium, Tesla is already looking to the next step: energy independence on a global scale. This involves a simple yet powerful question. Why rely on a scarce, expensive, and geographically concentrated resource when there is a more abundant, recyclable, and affordable alternative? Aluminum enters this equation as a key player. With over 700 million tons in global reserves and a presence on virtually every continent, it breaks the silent monopoly that lithium has established over the last decade. This monopoly is more real than it seems. Today, about 70% of lithium reserves are in just 3 countries: Chile, Argentina, and Australia. But the most sensitive data comes from refining. 85% of all lithium processing worldwide takes place in China. This means that even if a country extracts lithium in its own territory, it will likely have to ship it to China for processing. In times of geopolitical tension, this is a considerable risk, and Tesla isn't willing to play this game for much longer. With aluminum, the story changes completely. The United States, for example, produces more than 1.7 million tons of aluminum per year. And most interestingly, 95% of all aluminum can be recycled indefinitely, without significant loss of performance. This paves the way for a truly circular economy, where waste is transformed into new, energy-efficient products with a much lower environmental impact. It's a kind of quiet reinvention of the industry, something that sounds technical on paper, but has immense implications for the future of transportation. And this change isn't limited to environmental or strategic considerations. It directly impacts consumers' pockets. Currently, the average cost of a lithium-ion battery is around $15,000 per vehicle. Aluminum-ion batteries, according to Tesla's estimates, can be manufactured for less than $4,000. We're talking about a cost reduction of over 70% without sacrificing quality or safety. This puts electric cars at a price point never before seen, especially for those who thought electrification was still an elite pursuit. The Model 2 is the main symbol of this shift, a compact car designed to be affordable and durable that can carry the world's most advanced battery for a fraction of the price. It's no exaggeration to say that it was designed to be the global electric mass market, and not in the empty sense of the word mass market, but rather as something that actually fits into the budget of ordinary families. The impact of this is social, not just technological. It puts on the streets a vehicle that doesn't depend on subsidies or incentives, because its cost is already low by design. Furthermore, this production autonomy reduces the vulnerability of the entire supply chain. When an automaker can manufacture its batteries with abundant and recyclable raw materials, it no longer depends on unstable international negotiations or sudden price fluctuations in the commodities market. This provides stability, something that has become extremely rare in recent years. What's more, it allows for long-term planning, without fear of sanctions, blockades, or trade wars. Tesla knows it's picking a fight with an entire industry, but perhaps that's precisely what it's aiming for. By abandoning lithium, it positions itself not as just another electric car maker, but as a platform for energy autonomy. A car that charges quickly, lasts decades, costs less, and can be manufactured without relying on strategic rivals is more than a product. It's a statement of industrial sovereignty. And in the current scenario, that's as valuable as the technology itself. What truly sets this battery apart, however, isn't visible to the naked eye. The secret lies in a nearly invisible technology called graphene quantum dots, tiny particles measuring just 1 nanometer, about 10,000 times thinner than a human hair. These microstructures act as tiny guardians within the battery, organizing the flow of electrons with surgical precision. And it's precisely this organization that prevents the appearance of the dreaded dendrites, those needle-like formations that can puncture cells and cause short circuits in lithium batteries. Inside the Model 2 battery, these graphene quantum dots aren't there by chance. They're strategically positioned in 2 critical regions, along the aluminum anode structure and in the separation layer between the cell's poles. This ultra-thin array acts like an electronic safety net, guiding electrons along the right path and keeping everything under control, even under extreme conditions. Instead of letting electrons run wild, as happens in many current batteries, they travel along well-defined routes, like cars on a highway with no traffic. This intelligent driving brings practical and measurable results. By reducing the cell's internal resistance by up to 95% compared to lithium-ion batteries, graphene quantum dots ensure that virtually all of the battery's energy is used to power the car, rather than heating its components. This translates into direct efficiency, less energy loss, and more power at the wheel. And when it comes to recharging, the impact is even clearer. The presence of these graphene dots allows for charging speeds up to 10 times faster, without the risk of overheating, something that previously seemed impossible. The most curious thing is that all of this is done with an almost symbolic amount of material. For each Model 2 battery, just 1 gram of graphene quantum dots is needed, the equivalent of a grain of rice. A tiny detail, but one that transforms the entire system's operation. It's one of those cases where the smallest component ends up being the most decisive. And more importantly, this technology isn't just on paper or locked away in a lab. It's already validated in real prototypes, ready for mass production. Most companies researching advanced batteries are still stuck in controlled environment testing or facing cost challenges to scale their technologies. Tesla, on the other hand, is already setting up supply chains and production lines ready to manufacture these graphene quantum dot batteries in volume. This gap between idea and execution is what often separates the pioneers from the laggards. Having the technology isn't enough. You need to know how to reliably deliver it to consumers. And with this solid foundation, Tesla can race ahead for years. By the time other automakers finally achieve something similar, it's quite possible that the Model 2 will already be 2 generations ahead, with additional improvements that haven't even been revealed yet. This creates a gap that's difficult to recover, especially in a market where innovation and responsiveness are everything. What seems futuristic to some today is already becoming standard for Tesla. For the average driver, the results of this discrete technology are immense. It's not just about fast charging or energy savings, it's also about safety, stability, and longevity. These microscopic particles help create a battery that not only delivers more performance, but also lasts much longer and operates much more reliably, even under intense stress. It's the kind of quiet innovation you only notice when you realize you don't have to worry about it anymore. If the battery is the heart of the Model 2, then its brain is the QNP1 chip, a component almost as revolutionary as graphene quantum dots. Hidden under the car's center console, this processor isn't just another control chip. It represents a new way of thinking about the relationship between car, driver, and energy. Integrated into the vehicle's nervous system, the QNP1 collects real-time data on driver behavior, interprets physiological signals, and adjusts battery performance with almost surgical precision. It doesn't just react, it anticipates. The magic happens because the QNP1 is powered by a network of biometric sensors that capture information such as muscle tension, eye movements, breathing patterns, and even pupil dilation. Based on this data, the chip can predict up to 85% of the driver's movements before they even happen. For example, if it senses the driver is about to accelerate suddenly, the system redirects energy to the supercapacitor, preparing an immediate boost. All this happens in milliseconds, silently, almost imperceptibly. This level of intelligence brings real efficiency gains. The QNP1 can adjust the battery's operating mode based on the driving style and specific needs at any given time. If the driver is on a quiet, urban route, the system prioritizes energy conservation and reduces battery wear. In high-demand situations, such as hills or overtaking, the chip automatically adjusts power delivery. This adaptive management can increase energy efficiency by up to 25% and reduce battery wear by up to 30%. More than just extending its lifespan, the QNP1 makes the driving experience much more personalized. Traditional driving modes, sport, economy, comfort, are becoming obsolete. Instead of choosing between them, the car chooses for you. Contrary to popular belief, this choice isn't random. It's based on how you're feeling, in real time. If the chip detects that the driver is relaxed, it softens the steering, accelerator, and even the interior lighting. If it senses tension or heightened focus, it hardens the car's response, as if preparing for an emergency. This type of adjustment creates an emotional bond between human and machine that goes beyond simple use. The car adapts to your mood, and this builds trust. It's not just comfort, it's mechanical empathy. And this extends to the recharging process as well.